Okay, in this video, we're going to compute these limits right here. In fact, they are not that bad at all. Not only because they are all similar, but the best part is we have our CQ weapon, namely the limit to help us out. And we will see how we can change this right here into the form that we like, and then we'll make use of that. Well, take a look at these three. Which one is the easiest? And you tell me number 3. So let's get started with this. Notice that everybody is in the form of infinity times 0. If we put infinity to here, infinity square, that will give us infinity. And then infinity down here, 1 over infinity square is 0. Sine of 0 is 0. So that's the idea. Anyway, we'll utilize this right here. That means we should take care of the x square in front. And to do so, well, take a look. This is the limit as x approaching infinity. I'm going to keep the sign of 1 over x squared on the top, but I'm going to bring the x squared down. So it becomes 1 over x squared down in the denominator of this right here. And of course, if you multiply the top and bottom by x squared, you will get this back. So they are equivalent. So that's the idea. And now you see this and that are exactly the same. So you can just do some change your variables. That will be really nice. I will say that theta equals to 1 over x squared. Now check this out. Earlier we had the limit as x approaching infinity. Now if we put infinity down here, you get 1 over infinity squared, and that will be 0. That means theta will be going to 0. Very nice. And then, of course, we can just take this right here. We have the sign of theta, because 1 over x squared is theta, and then over 1 over x squared is again theta. And congratulations, we have exactly the limit. Namely, the answer to this is just equal to 1. That's it. Now, let's do number 1 first. Why not? We will do the same thing for the first step. Namely, we will put the x down below in the denominator. Down actually. You see, this is going to be the limit as x approaching infinity. Keep this on the top. We have sine of 1 over x squared, like this. But we will bring this down, and we get 1 over x. This time, unfortunately, this and that are not the same. But it's, again, a good idea to let the inside be our new variable, namely theta. So let's see what will happen. Let theta equal to 1 over x squared, right? Again, same speech. Here we will get the limit. Earlier we had x approaching infinity, so now theta will be going to 0. That's very nice. On the top, this is nice. We have sine of theta. That's great. Then, what do we do on the bottom though? We have 1 over x. Well, you see that 1 over x squared is theta, so we can just take the square roots on both sides. Just take the positive version, of course, because everybody right here is positive. This means 1 over x is equal to square root of theta, right? So on the bottom here, we have square root of theta. And now we have to handle this carefully, because this is not exactly the same as the limit. We don't want the square root, so we have to think about it. So what can we do? Well, what do we usually do when we have a square root? Well, how about let's just multiply the top and bottom by square root of theta. How's that? Sure, why not? Now, have a look here. This is the limit as theta going to 0. And you see, if you pair this up, this right here will get sine of theta over this times that is just theta. That's good. But we still have the square root of theta on the top. Well, you can put it down right here, but here's the idea. We can use the limit law, meaning that we can take the limit of this times the limit of that, right? Well, so here's the write out. You can write this down, and then I will just write this down again. Multiply by the limit as theta going to 0 of square root of theta, like this. Again, this is the product of this part and that. And when we take the limit of a product, because both limits exist, so we can just do the product of the limits like that. Anyway, here we go. This part, thanks to the limit, is equal to 1. And for this part, Well, we can simply put 0 into here. Square root of 0 is just 0. So in the end, we have 1 times 0. And of course, all in all, we get 0 for the answer. That's it. Now, number 2. Similar thing. So let's see what we get. So here is limit as x approaching infinity. Again, x squared. Put that down. So we get sine of 1 over x over 1 over x squared. And again, it's a good idea to let the theta equals the inside. So I will write down theta is equal to 1 over x. And now we see that this limit becomes the limit as, well, we have the theta now. X approaching infinity, put it here, we get theta is 1 over infinity, which is 0. So theta will be approaching 0. And we are going to pay attention to this 0. And you'll see why in a second. And here we will have sine. And the 1 over x is the theta. So we have sine of theta right here. And over, well, here we have 1 over x squared. That's just 1 over x times 1 over x, meaning theta times theta, right? So let me just, if you would like, you can still do this, square both sides. And we end up with 1 over x squared being equal to theta squared, and that's theta times theta. And you know why I want to do that? Because you'll see this part will give you what? The limit. And the other part is that you have the theta on the bottom. So we'll do what we did over there. Alright, so focus on this, and I'm going to break it down as follows. This is the limit as theta approaching 0, and then here we have the sine theta over theta, and that's going to give us 1. That's nice. Then I'm going to write down this part, right, which is the 1 over theta. Again, the limit as theta approaching 0, and then we have the 1 over theta here. Now, this right here is just 1. That's easy. That's done. But this part, you have to do it really carefully. In fact, if you just look at the limit as theta approaching 0 of 1 over theta, well, we don't have the plus minus, so what does that mean? That means we have to do both. But the truth is, well, if you look back, right? If you look back, because x is approaching infinity, so if you put infinity to here, it's 1 over infinity, and everybody is positive. That means theta is approaching 0 plus only. 0 plus only. So you'll come back here and say this is 0 plus. Likewise, this is also 0 plus only. In fact, I should have done that for everybody over there. This right here should have been a 0 plus, 0 plus, 0 plus, and all that. But the deal is, it didn't really matter. Well, it kind of did. You cannot put 0 minus in the square root. So anyway, that's what I should have done. And like right here, it's same idea, but you know, why not? And this limit, of course, it works for 0. That means it works for 0 plus and it's also 0 minus and all that stuff. So this is still 1. And now, if you put 0 plus in here, 1 over 0 plus, because everybody is positive, we will end up with positive infinity, right? So again, here's the deal. X is approaching positive infinity. That means theta is technically approaching 0 plus, and it matters especially this part right here. So you have to really look at it carefully. All in all, 1 times infinity is still infinity. Whoops. So we just put this down, and then we are done. Alright, so that's it. Hopefully you guys like the secret weapon. Anyway, as always, that's it.